Nintendo Switch board only. Let me show you what's going on. Apparently a toddler kept jamming this Nintendo Switch into a port, and this was the result. So we're going to be doing some trace repair on this one today. And the first thing I'm going to have to do is some cleanup. So while I set up my equipment, let me throw in my expected temperatures for this job. These temperatures are brought to you by the associate links in the description. If you go to my video description and click on one of these links and buy any of this equipment, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. Back to microscope. Let's add some flux to our situation. And let's clean off all these pads first. Gently. Don't need to create more work. We need to add some low melt to these anchors. Otherwise we will never get that solder out of there. Low melt makes life a little bit easier. This part of the job. Having to adjust to the new setup a little bit, so y'all may have to be patient as I figure things out. You can set it up with your brain all you want, but until you've actually put it to use, you don't know what works and doesn't work. Alright, clean up so we can see what's going on. I have a few areas of concern. So these guys here are all straightforward. No big deal. I'm a little concerned about these down here. I'm hoping they're just ground, but we will test and see. If not, they're going to be a little more of a challenge. Alright, let's grab the multimeter. Stick one probe on ground. Okay, that one's definitely ground. That's good. That one has a nub. What about this one? What are you? Having a little bit of a challenge making contact. This one's definitely ground. This one is not giving me... We have to do some scraping here. Let's grab our handy dandy pin grinder and see if we can't get to that nub a little bit. You can find the pinouts on these pretty easily, but you can also figure them out with your multimeter. We'll try the multimeter first and then we'll look it up. Alright, we're going to have to look that one up because that via is toast, I think. And if it's not ground, that means we're going to have to run a wire from somewhere. Let me look up a guide and see what we can find. As you can see, the pad in question is actually a ground pad, so we need not be concerned about it. We'll just continue with our work and leave that one blank. Go from there. Thanks to Tech Time with Thomas for the guide. For your orientation purposes, we will begin our work on side B in this area, and then we'll flip to side A and work in this area. I think this trace is salvageable. It's not really moving right now. It should be fine. The only ones we need to be concerned about are these ones with the little nubs. That's good news. So this pad is ground, this pad is ground, and this pad is ground. We do not need to run those because pretty much the whole port is ground other than the signal lines. This is ground, the whole shield is ground. It'll be fine. In an ideal world, you have them all, but when you're running traces, you don't want to run redundant traces. I would do some scraping, but they've pretty much been scraped and tinned as it is, so we will add more solder to those little nubs so that we can solder wire. Robbed of the pin grinder today. We'll be switching to our Pico pencil for majority of the rest of this. So we need little blobs of solder. These nubs, some of these nubs will be easy, some of them will be more challenging. The smaller they are, the more challenging they can be, but we will get it done. We're going to switch from our blue mechanics to our black Inesi tweezers. The black Inesis are a great tweezer for manipulating wire. Let's see if I have any wire the size I want for this job. I'd love to tell you what wire size I'm using, but none of the spools I have came with labels. I was able to buy a lifetime supply of wire from a surplus company, but labels were not included. Now we're going to scrape off some of this enamel, burn it off, scrape it off. A lot of it. Just enough to solder. Start soldering to nubs. Alright. Nice and solid. Let's continue on to our nub. Acceptable. We'll get some pin grinder action because I forgot we do need to run this long one. And I'm going to run it up here because we're going to need to secure it down. It could float off if we just solder it to that pad. And this one we're going to do some routing on. Scrape off a little bit of our enamel. I may even run them a little bit long just to get more security. There we go. That is a nice joint. Run them along on this side. Give ourselves some slack to route. You're going to need to jig over a little bit. Like that. And like that. We're going to need to secure this pad down once we do the coating. Alright, this is one of the ones with the tiny nub. This one will be pretty delicate, so we're going to be careful with it. I really like more solder on that joint. There we go. That's what I want to see. We don't want to just surface stuck. We want it covered in solder, ideally. There we go. Tedious work, guys, but it's part of the business. If you can get good at this, you can get work. There are even some really experienced guys with soldering irons. They have a hard time with this level. Scrape this one off. Alright, this is another one of those tiny nubs. It's going to be a little bit of a challenge. Okay, I'd like to run it a little long so I can get more security. There we go. By long, I mean run it a little long here so I can put some solder mask on to help hold it down. It's not being held by much of a joint there. Anything we can do to assist within reason. Again, small nub here. Again, I want to run this one a little bit long. Alright. Maybe as good as we can do on that one. We'll have to be pretty careful during cleanup. I think we have everybody who is critical. Now comes the part where we need to be very careful. And we're just going to brush one way. Put it down, brush, pick it up, put it down, brush, pick it up. Do not want to scrub back and forth, not even accidentally. We will probably enlist the ultrasonic brush here momentarily. We need to get all the flux out. Get all the flux out between all those wires. Flux and UV coating do not mix. See how we're doing. There's still a little bit in there, but we're doing all right. Alcohol is cheap. Most of the time. Same thing here, you just want to brush one direction. And it's completely dry. Next task. Still some tediousness. We're going to solder mask these in place. We're going to put solder mask all over this one. And then we'll just scrape it off after. I just want to secure that loose pad down. The best way to do that is to cover it completely and then scrape off the area you need after. You could technically do that with all the jumpers. You might get some argument about which way is the best way to do it. Just don't like to spend a whole lot of time scraping for minimal gain. Uh-oh, did we lose a wire? I think we lost a wire. We will secure these down first and then we'll address that one. I don't know when that happened. Like I said, those little nubs can be quite a challenge. Let's go ahead and make sure we get all these guys in place before we go adding flux and dirtying things up again. Everything covered that we need covered here? I think so. I have placed our lamp. I'm going to step away, take a break, just let it do its thing, find my coffee, and wait for this to get a really good cure, and we'll be back. Let's have a look, see if we're cured. Everything feels rock solid here. That's good because we need to address that one wire that got knocked off somehow. Some flux back on here. Some solder on that nub. Yeah, this is why we secured all the rest down before we worked on this. Let me find another tip. Let's do this one. Temporarily change to a finer tip and get some solder on that nub. There we go. That's what I needed for. Let's try to solder him on. Alright, he's on really good. So I don't want to mess with it if it's on really good already. Clean it again so we can put coating on it and protect that one. Again, we need to get all the flux out of there. We'll worry about the overhanging wire after. Grab our lamp again, gently set it on there, give it another good cure, step away for a few minutes, and let it do its thing. Let's see if we're solid. I do believe we are. Nice, rock solid. Life hack, if you need something to do while you're waiting on a cure like this, throw some weights in your lab. You can do some reps while you wait. There's a lot of hurry up and wait in this business. Might as well do something healthy, right? Yeah, you just can't afford to be impatient with the curing. Stick it on there, step away, go do something. Let's do some scraping. If you don't get a good cure, your wire ain't going to stay in place for this. Clean it off. Should be able to scrub normally here if you got a good cure. Flux everything up with thinner wire. Another good test for your cure. If you don't get a good cure, it's very likely your wire will get sucked up by your iron. And the reason why you want to expose that before you put the port on, if you pre-tin the port like I do, the solder on the port could suck up your wire as well. Ask me how I know. Add some flux to our port, and with a ball of solder on our tip, just gonna run it over the pins. Not really trying to make any contact with the pads necessarily, but you'll make incidental contact. It's not a big deal. Sexy. Place our port. Alright, approach wise, we're not going to really change anything with a hard air. I'm going to rapidly move our nozzle and let heat accumulate on the board. The heat will eventually accumulate enough to wet the solder. Though with jumpers, you may have to be patient. It may take a few tries to get every pin connected. We're looking for that solder to wet. We're moving it rapidly so we won't burn anything. We're concentrating really on the inner row. I don't really care about this outer row too much to begin with. Okay, hold it down, wait for evidence that the solder has dried. Conduct a little nudge test. Feels pretty solid. Now we'll look at this outer row. I think we'll need to address that one jumper pin at least. That one was the ground. We're not worried about ground. And we're just going to go over these outer pins. Some of them didn't get soldered. The ones we were worried about on the inner row anyway, so that's all good. The important ones are the ones you can't see. Alright, I think we're solid on everything. We're going to flip the board to side A. Do some work in here. A big chisel. A little bit of solder on the corner here. Get things started. We want this solder to climb up the leg pretty good. So put a generous amount in. Doesn't take a whole lot on these ones down here. See how we did? Looking good. Now, because this is a port, we want to clean it up real thoroughly. We don't want no gunk in the port messing with our testing. We cleaned it up and we're ready for power testing. A few changes. I have tied all my Nintendo Switch cables to PSU channel 1, so we'll be watching that mostly. PSU channel 2 will probably be reserved for power injection purposes going forward for these videos anyway. On this test, I'm just looking for some evidence that the switch is recognizing the charger. It is not always a reliable test, but it's one I like to perform just to see what it's doing. Not so much on that side. We will be using a battery today because I need to know that it's charging on both sides. Yeah, we're not really much going on there. We're definitely going to hook the battery up and get a different test going here. We'll use the battery in my housing. Let's plug it up and see what we're doing here. I'm not getting any evidence of life at all here. That's not a good sign. We are booting on that side, but the other side was not doing anything. Oh wait, we're fast charging on that side. And we're fast charging on that side. Okay, let me find my dongle. Complications of a new setup. We may need to reflow this port. We'll go ahead and do a dock test just to be sure. Let's reactivate the switch. OBS is being flaky, acting like I have too many sources, even though I hasn't changed from before. Fun. We're still powered on. Okay, let's try to the capture card. Nothing. Still nothing. Any docking at all. I think we're going to reflow this port. Okay, let's reflow our port. Rapid air movement again. We're going to need to wet all those anchors, but they will assist in pressing this port down once we push it down again. Okay, we are thoroughly wetted. Pressing down. A little harder this time. Continue holding it down. Wait for everything to dry. Once those anchors dry, they're pretty good. Now I'm going to want to clean this thoroughly again. Alright, let's test again. We're going to continue testing with the battery because I need to know if it's charging on both sides for sure. This is the most important thing we're trying to solve right now. That is not a good sign. That's booting. At a reset. Okay, we're fast charging. Check the other side again. Oh, we're fast charging on the other side now. Still not getting docking. Okay, I was getting it from both sides a moment ago. You guys saw it. We're still not making total contact here. Makes this one particularly slow. Every time you have to do a reflow, is you need to clean it up every time because you don't want to gunk up all your connectors and chargers with flux. Cross our fingers. Pray for me. That's not what I want to see. I'm not even getting one side here. I'm getting no recognition from the other side. This is going spectacularly bad. I'm having an issue with my cable. Something ain't making a sense, so that's going to have to be the plan. Remove the port, take a look, see if we lost a jumper. This is always a danger of using somebody else's parts. You just never know what is going on. So everything is wetted before I try to lift this port. Heck no, every jumper is there. What on earth? What is the issue then? Every jumper is there and solid. I'm going to pull one of my ports and do it. That'll work. I am not typically a hot swap guy, but in this case it may actually aid us to have the anchors. So we're going to wet everything here. We're still going to have to flow the solder on the ports, but hot swapping is very awkward for me. Okay, let's get these pins wetted. And hold it down till everything dries. Check our outside pads again. Okay, everybody's connected on the first try that time. Clean it again. And something strange was going on because I usually don't have to reflow. Let's see how we did. It felt pretty good, but that doesn't mean it was good. Feelings don't matter. Flat zeros is not what we're looking for. Wow, this is being a really painful repair. It's amazing. Still getting one side charging, it appears. I'm gonna grab the breakout board and we'll do the fun testing. Okay, I'm fairly convinced that it's the chip. This is the breakout guide for the breakout board I'm using. Thank you, Play It Again Retro Video Games. And as you can see, the signal lines on this side correspond with those test pads. Now, I don't go through here and just read these exact signal lines. I'll show you what I do. I put one probe on one of the test pads that should read out, and then I just run my other probe down the line. And we had a signal to every test pad that we needed to have signal to. I also did this for the other side. As you can see, every one of those filters in line with the Pi 3 USB on side A should have a signal. So again, so what I do is stick a probe. I actually use these capacitors right here for the ones that have them. And I stick a probe on there, and then I just run my probe down the line, and you should get a signal for one of these on each one. As long as I get a beep on every one of those filters, I know we're getting a signal. So I know we're getting a signal on every line that we should be getting a signal on, which tells me the probe is good. So at this point, I am left to believe that we have an M92T36 problem, and I'm going to need to contact the client and let him know there will be an additional cost and go from there. I've gotten clearance from the client to proceed with the M92T36 replacement. I have run it through the battery of tests, our common fault testing zones and all that, and nothing's coming up. But as I said, I've gotten signal from every line on the port, so we're left with this as the probable issue. So we're going to change it out and test from there. We're ready to change the chip. If you can see up there on the bench cam, I have the chip staged right here in the orientation I need. So the idea is we're just going to quickly swap it out. We don't need to test because there was no short to begin with. Hopefully this will be a good chip and we won't have any issues, but I did have some issues with the last switch I did on this lot. For your orientation purposes, we are now working here on side B. The M92T36 is located here. I'm not doing this in the orientation of the board view, sorry. I'm waiting for every pad to wet. Pull the chip. I'm going to re-wet the solder. We're particularly looking for that center pad to wet. We need it to grab onto the chip before we let it go. Center everything up as good as possible. That's not as good as possible. Now it's flowing off everywhere. Okay, I'll grab it. Try this again. That was not a very successful placement. Take a few weeks off. Does that mean I can't solder it? Take the heat off. Let it tack down. Press down. Re-wet. Adjust if it needs to be adjusted. And I'm adjusting it all over the place. See how we did? Appear to be well aligned there. Well aligned there. That looks good. Line there. And a line there. Clean it off real quick. Okay, that looks good. Let it reset. If it would like to kindly reset now, that'd be good. Unplug the battery again. Let's try again. Okay, 0.46. Reset. Should be resetting. It is not resetting. Keep my orientation this way. I'm going to unplug the battery. See if we can get it to activate on this side too. Okay, it did activate on that side. So we're getting both sides, but it's not resetting and charging. Absolutely not normal behavior. Let's try with our dongle. My suspicion is another bad chip. That entire lot has been especially bad. Alright, let's try activating. Well, that sure seems to be booting to me. Maybe it just wasn't cooperating with the PSU. Could we get that lucky? Or is it just stuck? Sure looks like it's just stuck. I'm not optimistic we're going to get anything from this. Yeah, we should be getting fluctuations and such. I think we got a bad chip. Okay. I am thinking that chip is definitely bad. Looks like a boot and maybe go into an error screen maybe? Well, no, it's continuing to boot now. And we're docking. Okay. Well, that's weird. I may have to hook up a USB meter. Alright, so confirmed we do have a problem still. We're only pulling 5 volt from the OEM charger, as you can see in the USB meter, which may explain the weird behavior we're getting on the PSU. So we're on the OEM charger. We shouldn't be getting 5 volt. That's very strange. We're going to put another one on and try again. I'm going to try one of my pull chips. I've had too many weird things going on with this M92 T36 lot. And you can't really blame the parts brokers, because there's not really a reliable place to get the part. They're all getting it from China, wherever they can get it, and you just never know what you're getting. Not like you can go to DigiKey or Mauser and pick up an M92 T36. My placement is not awesome. I hope you're getting value out of this video. If you find this something you're not ready to tackle just yet, just a reminder, I do offer these services both local and mail-in. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. If you mention this video, I'll give you a 10% discount on this repair. Funny thing is, we've known our port is good for a long time. That's what it came in for. We're chasing other problems right now. Alright. Cross our fingers. Okay, please reset. And fast charge. There we go. That's more like what we're going to see. Flip it over. Please fast charge on this side. Yes, that's what we want to see. We know we're docking already. Now we're charging on both sides, fast charging. Now we need to make sure we are pulling 15 volts. For whatever reason, it's not showing on screen. I'm about had it up to here with all the problems I'm having today. But we are pulling 15 volts on the meter. So we're good. I'm going to check and make sure it's docking one more time. Okay, and as you can see, we're docking still. So that M92 solved it. That was one of my pulls. Everything from that other lot has been a disaster, as far as I can tell. But anyway, we're good. We're charging on both sides at 5 volt and 15 volt and docking. That's a win. All right, well, that was a little bit of rust and a little bit of additional problems and a little bit of bad parts. Hope you enjoyed it. If you got value out of this video, I think you'll get value out of this one, and I'll see you there.